What's Up, where we talk about all things electronics. I am your host, Emma Watson. Tonight, we're delving into the fascinating world of vacuum tubes with none other than the brilliant mind behind it all, John Ambrose Fleming. Welcome, Dr. Fleming.
Thank you for having me. It's a pleasure to be here.
So let's dive right in. We all know that today's technology is heavily reliant on transistors. But before those little wonders came along, how were these giant vacuum tubes? Could you tell our audience a bit about their history?
Absolutely. You see, transistors, those tiny marvels that power our modern world, made their debut back in 1947. But before them, there were these faulty fellows called fermionic bulbs or vacuum tubes. They were the predecessors laying the foundation for what we now call the information age.
Fascinating! And how did these vacuum tubes work?
The magic of vacuum tubes lies in their simplicity. Picture this. Inside the glass tube, we have electrodes, the cathode and the anode. The cathode, when heated, releases electrons through what we call thermionic emission. Applying a positive voltage to the anode attracts these electrons, allowing current to flow. And mind you, this all happens within a vacuum-sealed environment, ensuring a clear path for our electrons.
So it's essentially a dance of electrons within a sealed glass enclosure?
Precisely. And from there, we ventured into more sophisticated designs and were shaped into what we know now as transistors.
What an absolutely fascinating journey through the evolution of vacuum tubes. When we come back, we'll ask Dr. Fleming on how these vacuum tubes work. Find out how after this short commercial.
Vacuum tube ba? Hanap mo, may anode, cathode, vacuum tube, tawag sa gantong aparato. Fleming Ambrose, nagsimula 1904, isang banyaga. Cathode kapag ininitan electron, lilisan thermionic emission. Kaya, force device ba? Hanap mo, triode, tawag dito, may C-grid between cathode at anode. Ang mga electrons manabigan, pero may C-grid na kumakontrol. Kapag voltage mo high negative, bawal din negative electrons ay bababa. Diagram siya pabutihin lahat. Concept na simple gawing mahirap. Electrodes gawing apat. Tetrode na ang inyong katapat. Screen ng grid, frequency size 100 kHz, ito ay kapantay. Nakakabit, hindi to sa skies. Decouple to ground ang kaniyang ties. Di pa rin set ang panghuli. Ang kink na lang sumasangge. Malupit ang hinuli. May pentode na tube at iba ang kanyang grids. Electrodes, suppressor grids. To it! Vacuum tube ba? Hanap mo, di walang kink. Pentode, all grids. Electrode, sa tubes, all goods. Mga mata, nalulula sa dami ng tubes na pinakita. Lahat ng tubes and outs may thermionic emission na nagpakitang halaga.
Welcome back to What's Up! Now, before we wrap up, could you give our audience a quick summary of how this vacuum tube works?
Of course, picture thermionic emission as heating up a material to release electrons, acting to evaporation from a liquid surface. These emitted electrons are then attracted or repelled by electric fields, controlled by our electrodes, cathode, control grid, screen grid, and suppressor grid. And it's all about managing space charge, the cloud of electrons between cathode and anode, to ensure a smooth flow of current.
Now, could you explain a bit how vacuum tube cathodes work?
Certainly, cathodes play a crucial role by emitting electrons when heated. There are different types like directly heated cathodes, which are essentially the heating element itself, and indirectly heated cathodes, which are heated separately. And let's not forget about dull emitters and oxide-coated cathodes, each with their own advantages and drawbacks.
Thank you for that breakdown, Dr. Fleming. Now, what about the grids and anodes in these vacuum tubes?
The grid controls the flow of current in the anode circuit, allowing us to regulate electron flow. And the anode, typically cylindrical in shape, surrounds the cathode and the other electrodes, completing the circuit.
Brilliant! Well, there you have it, folks, a glimpse into the mesmerizing world of vacuum tubes, courtesy of the one and only John Ambrose Fleming. Thank you so much for joining us tonight, Dr. Fleming.
Ang boring naman nitong tungkol sa mga vacuum tubes na to.
Oo nga eh.
Sige na nga, next channel na. Parang gusto ko manood ng teleserye.
Ang susunod na programa ay Rated G. Ito ay pwede sa lahat ng manonood.
Flashback.
Ang naharaan sa Sparks of Friendship. Nasira ang power outlet ila Maxwell. Maayos kayo nila ito.
Aray, ito na naman? Oh, nangyari? Okay ka lang ba? It's the outlet again. Every time I plug the TV, there's sparks on it.
Looks like you've got a classic case of electrical trouble. Let's dive in and figure this out.
Alright, Maxwell, here's the deal. Mukhang ang rectifier circuit ng yung power outlet at namamalfunction is not converting the AC voltage properly. Hence, the sparks.
So, how do we fix it?
First, let's talk about half-wave rectifiers. They're like gatekeepers, allowing only one half of the input sine wave to pass through.
When the top of the transformer secondary voltage is positive, diode D1 becomes forward biased. It allows current to flow through the load. But when it is negative, diode D1 becomes reversed biased, acting as an open switch and resulting in a zero current through the load.
Wait, so ibig sabihin, ang flow ng ating current is nakadepende whether the diode is reverse or forward?
Exactly, and to ensure a stable output, we calculate the secondary voltage using formulas.
VRMS is equal to 1.57 times the average voltage. The root mean square of a half-wave signal can be determined by dividing peak voltage by 2. To calculate the peak secondary voltage, we multiply the secondary voltage to the RMS. The average or DC voltage is equal to 0.318 times the peak value of the load voltage. The period for one cycle is 1 divided by the frequency, where the output frequency is equal to the input frequency. Secondary voltage is computed through multiplying the ratio of NS and NP to input voltage. Vs peak voltage is equal to Vs times the root mean square. Peak capacitor voltage can be determined by subtracting the DC voltage from the secondary peak voltage.
Huh? Ang galing naman! Paano naman yung mga changes na sa voltage?
That's where the capacitor input filter comes in. It smoothens out the DC voltage, giving us a more stable output.
Exactly. It's like adding a buffer to even out a load.
Meron din tayong tinatawag na full-wave rectifiers. Both positive and negative cycles of the alternating current are utilized, improving efficiency and reducing ripple. And these are the following computations for the full-wave rectifiers naman.
The RMS value of a full-wave signal is 0.707 peak voltage. V1 peak voltage is equal to V2 peak voltage and can be computed with 1.414 times Vs over 2. DC voltage is equal to 0.636 times V out peak. Output frequency is equal to twice the input frequency.
And finally, we have bridge rectifiers. This clever contraption uses a bridge configuration to rectify AC voltage to maximum efficiency and minimal fuss. Kapag positive ang cycle, D2 and D3 are forward biased, at D1 at D4 naman ay reversed biased.
Kapag negative naman ang cycle, D1 and D4 are reverse biased, while D2 and D3 are forward biased.
So, by using rectifier circuits, we can ensure a steady power supply for our devices?
Tama!
Now, let's get your TV up and running, shall we?
Tara! Oh, ayan. Tapos na. Oh. Uy, pwede na.
Pwede na. Huh? Yung TV na naman siya.
Maayos kaya nila Maxwell, Edison at Tesla ang kanilang telebisyon. Abangan sa susunod na episode ng Sparks of Friendship.
Tama na yan.
Corny naman.
Mag-shopping na lang tayo.
Mga ka-shopping, magandang araw sa inyong lahat. Ako po si Capsidor at muli tayo magkakasama para sa isang espesyal na episode ng e-shopping. Ngayon, may handog tayo na tiyak magbibigay liwanag sa inyong mga proyekto at pangangailangan sa bahay. Are you ready to level up your electronics game? Sira ba ang inyong telebisyon, radyo at mga smartphone? Pwede nyo na yung itapon. Kung ayaw nyo naman, maaaring simple lang ang sira niyan at maaaring ito ang magbibigay solusyon para sa inyo. At ito na nga ang aming bidang produkto ngayong araw, ang ating transistor. Alam niyo ba kung paano ito nakakatulong sa inyong mga kagamitan sa bahay? Unang-una, tuklasin natin kung ano nga ba ang transistor. Ang transistor ay isang uri ng semiconductor device na nagpapalakas ng voltage, current, at power ayon sa pangangailangan. Kapag ang isang maliit na signal ay pinasok sa isang transistor amplifier, ito ay naglilikha ng mas malaking output signal, kung minsan ay daan-daang o libo-libong beses na mas malaki. Alam niyo ba na ang kasaysayan ng transistor ay nakatatak sa pagbabago ng ating teknolohiya? Noong 1947, nilikha ng mga siyentipiko mula sa Bell Laboratories ang unang working solid-state amplifier na tinatawag na point contact transistor. Isa itong malaking pagbabago sa mga bulky at power-consuming vacuum tubes. Ang isang transistor ay binubuo ng dalawang PN junctions na nabuo sa pamamagitan ng pagkakasandwich ng P-type o N-type semiconductor sa pagitan ng magkaibang uri. Meron tayong dalawang klase ng transistor, ang NPN at PNP. Ang mga reliyong ito sa ating transistor ay may kani-kanilang tungkulin. Ang emitter region ay kung saan nagmumula ang mga current carriers at palaging forward bias. Ang base region ay napakapayat at lightly doped, habang ang collector region ay ang pinakamalaki at palaging reverse bias. At ito ang schematic symbol ng ating transistor. Pansinin ang arrow sa emitter LED. Ito ay naka-outward para sa NPN at inward naman para sa PNP. Pero pareho silang nagpapalakas ng voltage, current, o power. Oh, mukhang may color na agad tayo! Hello? E-shopping hotline, you're speaking with Capsitor. Paano ko po kayo matutulungan?
Hello? Gusto pong malaman kung paano tinitwik ang ating mga transistors para gumana ito ng maayos.
Magandang tanong yan. Ito ay sa pamamagitan ng transistor biasing. Ito ay isang proseso ng pagtatakda ng tamang DC operating voltage o current conditions ng isang transistor upang siguraduhin maayos itong mapapalakas ang anumang AC input signal. Kaya para masiguradong maganda ang performance ng ating transistor, kailangan itong tamang-tama ang biasing. Ito ay nakasalalay sa tamang base current IP at choice ng collector resistor o RC.
Wow, galing naman po. Sige, bibili na po ako nito.
At yan ang isang happy customer na siguradong matutuwa sa kanyang bagong transistor. Kaya huwag nang mag-atubiling mag-order, mga ka-shopping. Mag-text lang sa aming hotline at tiyak na aming i-assist kayo sa inyong mga katanungan at pangangailangan. Kaya ano pang iniintay nyo? Bili na ng inyong sariling transistor at siguradong maayos ang inyong mga kagamitan sa bahay. Hanggang sa muli, happy shopping mga ka-shopping!
Vacuum tube ba? Hanap mo, may anode, cathode, vacuum tube, tawag sa gantong aparato. Fleming Ambrose, nagsimula 1904, isang banyaga. Cathode kapag ininitan, electron release ang thermionic emission. Kaya, forest device ba? Hanap mo, triode, tawag dito, may C-grid between cathode at anode. Ang mga electrons wanna be gone, pero may sigid na kumakontro. Kapag voltage mo high negative, bawal din negative electrons ay bababa. Trigonometry pabutihin lahat, concept na simple gawing mahirap. Electrodes gawing apat, tetrode na ang inyong katapat. Screen ng grid, frequency size 100 kHz, ito ay kapantay. Nakakabit, hindi to sa skies, di couple to ground ang kaniyang ties. Di pa rin set ang panghuli, ang kink na lang sumasangge. Malupit ang hinuli, may pentode na tube at iba ang kanyang grids. Electrodes, suppressor grids, to it! Vacuum tube ba? Hanap mo, di walang kink, pentode, all grids, electrode, sa tubes, all goods. Mga mata, nalulula sa dami ng tubes na pinakita. Lahat ng tubes and outs may thermionic emission na nagpakitang halaga.